Let's talk about transformations, which is basically all of the different ways that we can move figures around. There are 4 basic transformations, and in this unit we're only going to be talking about 3 of them. We'll talk about translations, which is moving a figure up, down, left, or right. Reflections, which is flipping a figure over a line. And rotations, which is turning a figure a certain number of degrees around a certain point. There is another type of transformation called a dilation, which is something that we'll be talking about in Unit 6, which is in Semester 2. And by the end of this unit, we'll also talk about how to combine different transformations into one transformation, which is called a composition. For example, you could both rotate and translate a figure. That would be called a composition of transformations. In this lesson, we're going to be focusing on translations, but before we start with translations or any of the other transformations, let's learn some basic vocabulary that we're going to be using for all of these different transformations. The original shape is called the preimage. So whatever you're given to start with, before you do any transformations to it, that shape is called the preimage. Which of course means that whenever you're done performing the transformation, that new shape is called the image. The vertices of a preimage are labeled with just normal letters, for example, triangle ABC. But the vertices of the image will be labeled with apostrophes, and those apostrophes are pronounced prime. So triangle A prime, B prime, C prime would be the image of triangle ABC. When we get to compositions of transformations, you'll see that there will be multiple apostrophes depending on how many different transformations were performed. So you could have something like A double prime, B double prime, C double prime. The types of transformations that we're going to be learning about in this unit are called isometries. An isometry is a transformation that preserves the lengths, the angle measures, and the parallel lines that existed in the preimage. Basically, you're just moving the shape, you're not actually changing the shape. These types of transformations are sometimes also called rigid transformations. Rigid transformations include translations, reflections, and rotations. Those are the isometric transformations, or rigid transformations, and those are the types of transformations that we'll be learning about this unit. We're leaving dilations for a future unit because they're non-isometric, which means we'll have to learn some other information first before dilations really make complete sense. You should probably highlight those last 2 sentences or put a star next to it or circle it or do something to draw your attention to which types of transformations are isometric and which ones are non-isometric, because that is something that I'll expect you to be able to identify on some of the questions we're going to look at today. Let's look at a visual representation of each of these transformations. The first one you see is a translation. I just moved the light green triangle to the right to become the dark green triangle. The light green triangle would be the preimage, because that's where we started, and the dark green triangle would be the image. So since the only thing I did was move the triangle to the right, I didn't change its orientation at all, that's called a translation. The transformation in the middle is a reflection, because the light green triangle was flipped over that vertical line to create the dark green triangle. They're in a different orientation. The triangles are basically pointing in opposite directions. That makes it a reflection. And the final transformation on the right-hand side is a rotation. The light green triangle was rotated or turned around a certain point for a certain number of degrees to make the tilted version that you see for the dark green triangle. These 3 transformations are isometric. All of the triangles that you see on the screen right now are all the exact same triangle. They're just in a different place or in a different orientation. So that makes them isometric, which we also call rigid. But let's look at a non-isometric transformation. This is called a dilation. The light green triangle got bigger, or the technical term for that was enlarged, to become the dark green triangle. Since those 2 triangles are obviously not the exact same triangle, this is a non-isometric transformation. So let's look at a few examples and identify some important information about each transformation. For example, looking at this transformation, which triangle is the preimage and which triangle is the image? In other words, which triangle came first and which triangle is the result of the transformation? Well, the easiest way to tell that is just based on which triangle has the apostrophes, because that is the image. So triangle ABC, this guy up here, that's the preimage. That's what we started with. And then it became triangle A prime, B prime, C prime after it was transformed. Well, what kind of transformation was it? This was a reflection. Specifically, it was reflected in the x-axis. You could think about this kind of like an arrow that triangle ABC was pointing down, and now it's pointing up. It was reflected. It was flipped over that line. So is it isometric or non-isometric? It's isometric. Reflections are always isometric, meaning that triangle ABC and triangle A prime, B prime, C prime are the exact same triangle, just in a different place with a different orientation. How about our next transformation? Which one is the preimage and which one is the image? Remember, all you have to look for to answer this question is which one has apostrophes and which one doesn't. The preimage is the one with normal everyday letters, and the image is the one with apostrophes. So triangle DEF is the preimage, that's where we started, and triangle D prime, E prime, F prime is the result of the transformation. But what kind of transformation was it? Well, these two triangles are in the same orientation. D and D prime are both on top, E and E prime are both in the bottom left, and F prime are both on the right. The only difference between these two triangles is that it was moved to the right. That makes it a translation. And translations are isometric transformations because they are the exact same triangle. DE was 3 units long, D prime E prime is 3 units long. EF was 7 units long, E prime F prime is also 7 units long. DE and EF were perpendicular, D prime E prime and E prime F prime are also perpendicular. All of the things about both of these are exactly the same, they're just in a different spot, and that makes it isometric. But what about our next transformation? Which trapezoid is the preimage and which one is the image? Well, the preimage is the one without apostrophes, so GHIJ. And the one with apostrophes is the image, G prime, H prime, I prime, J prime. This is our first time naming triangles and quadrilaterals. When you're naming a triangle, you do put a triangle symbol in front of the 3 letters, but when you're naming a quadrilateral or anything bigger, like pentagons or hexagons or dodecagons, you just write the letters. So that's why you see on the screen here, I don't have a little trapezoid drawn in front of these letters. Since it's 4 or more letters, you just write the letters. But what kind of transformation was this? Well, it was a dilation, because trapezoid GHIJ became smaller to become trapezoid G prime, H prime, I prime, J prime. We actually call that a reduction, which is what we'll learn in semester 2. For now, all I need you to know is that this is non-isometric, because the sizes of these two figures are obviously different. It's a non-isometric transformation. And for our last transformation, which triangle is the preimage and which one is the image? Well, triangle KLM would have to be the preimage because there's no apostrophes, and triangle K prime, L prime, N prime would be the image. And the type of transformation that was performed is called a rotation. You can think about this triangle like an arrow or half an arrow pointing to the right, and then the image is half an arrow pointing down. That's a rotation, specifically of 90 degrees, and we'll learn more about that in a future lesson, but this was rotated 90 degrees clockwise. And since it's a rotation, it's an isometric transformation. These two triangles are the exact same triangle. And that's the basics of what you need to know about identifying transformations. In our next lesson, we're going to focus specifically on how to perform and identify translations.